In this video, we'll talk about the second major type of machine learning problem called unsupervised learning. In the last video, we talked about supervised learning, and back then we got data sets that look like these, where each example or each data point was labeled as either a positive or a negative example, right? So either a benign or a malignant tumor. And so for each example, we're told explicitly what is the, quote, right answer, whether it's benign or malignant, let's say. In unsupervised learning, we're given data without any labels. So we're given data in unsupervised learning that looks like this. We're just given a data set and not told what is what, but we're just told, well, here's a data set. Can you find some structure in the data? And given this data set, an unsupervised learning algorithm might, for example, decide that this data lives in two clusters. So it might decide that there are two types, two categories, and break the data set into two clusters. So this is called a clustering algorithm, and it turns out to be used in many places. So one example of where clustering is used is in Google News. If you've not seen this before, you can actually go to news.google.com to see for yourself. But what Google News does is it goes and looks at tens of thousands or hundreds of thousands of news stories found on the web, and it groups them into cohesive news stories. So for example, let's look here, right? So the different URLs here correspond to different news articles that are on the same, BP Allwell story. So let's say I click on one of these links, I get to, say, this webpage, which is a Wall Street Journal article about, BP kills the McConnell well. If you click on a different one of those links grouped together, you find a CNN article, right, on BP company sealing the Gulf Coast oil well leak. If you click on a third link, you find a Guardian news article about basically the same story. And so what this software has done, what Google News has done, is looked at tens of thousands of news stories and automatically clustered them together so that the news stories that are all sort of about the same topic get displayed together. It turns out clustering algorithms and unsupervised learning algorithms are used in many other problems as well. Here's one on understanding genomics. So this is what's called a DNA microarray data, but the idea is you get a group of different people, a group of different individuals, and for each of them, you measure how much they have or do not have a certain gene. Or technically, it's actually how much different genes are expressed. But so the colors, green to red, show the degree to which different individuals have or do not have different genes. Again, it's really the degree to which they express different genes is what biologists call it. And what you can do is run, again, a clustering algorithm to group individuals into different clusters, so automatically group individuals into different types of people. And once again, this is unsupervised learning because we're not telling the algorithm in advance that, there's type 1 person, type 2 person, type 3 person, and then we want to find these types. Instead, we're saying, here's a bunch of data. I don't know what's in this data. Can you automatically find structure in this data? So because we're not giving the algorithm the right answer for each individual, this is unsupervised learning. Unsupervised learning or clustering is used for a bunch of other applications. So it's used to organize computer clusters. So I've had some friends working on looking at a large data center, a large computer cluster, and trying to figure out which machines tend to work together. And if you can put those machines together, you can make your data center work more efficiently. Social network analysis. So given knowledge about which friends you email the most, or your Facebook friends, or your Google Plus circles, can we automatically identify which are cohesive circles of friends, or which are groups of people that all know each other? Market segmentation. So many companies have huge databases of customer information. So can you take a look at this customer data and automatically discover market segments and group your customers into different market segments so that you can sell to your different market segments automatically? And again, this is unsupervised learning because we just have all this data, right? We don't know in advance what the market segments are going to be, and the algorithm has to discover the market segments themselves. And finally, it turns out unsupervised learning algorithms are also used for, surprisingly, maybe astronomical data analysis. And these clustering algorithms actually give surprisingly interesting theories, useful theories of how galaxies are formed. So this is one type of unsupervised learning. Let me tell you about another one. I'm going to tell you about the cocktail party problem. So you've been to a cocktail party before, right? Where, you can imagine a room full of people and lots of people are talking at the same time. So, all these overlapping voices, and it's almost hard to hear the person that's right in front of you. So imagine with a cocktail party with, 2 people, so maybe somewhat small cocktail party. And we're going to put 2 microphones in this room. So because these 2 microphones are at different distances from the 2 speakers, each microphone records a different combination of these 2 speakers' voices. Okay, so maybe speaker 1 is a bit louder in microphone 1, speaker 2 is a bit louder in microphone 2, because they're at different positions relative to the 2 speakers. So let's say I collect these microphone recordings. Here is actually a raw microphone recording collected by a researcher. Let me actually play this audio clip.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
All right, maybe not the most interesting cocktail party, but it's 2 people counting from 1 to 10. But there you go. And so that's the first microphone recording. Here's the second.
1, 2, 3, 4, 5, 6, 7, 8, 9, y 10.
So what you can do is take these 2 microphone recordings and give them to an unsupervised learning algorithm called the cocktail party problem algorithm. And what the algorithm will do, and tell the algorithm, find structure in this data for me. What the algorithm will do is it'll discover that, gee, looking at these 2 audio recordings, it looks like there are actually 2 audio sources that are being added together or being summed together to form these 2 recordings. Moreover, what the algorithm can do is separate out these 2 audio sources. And in fact, here's his first output.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So separated out the English voice as one of the sources, and here's the second output.
1, 2, 3, 4, 5, 6, 7, 8, 9, y 10.
It's not bad. And just give you one more example. So here's another recording of maybe another similar situation.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
All right, so now the poor guy's gone home from the cocktail party and he's sitting in the room talking to his radio. And here's the second microphone recording.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
And when you give these 2 microphone recordings to the same algorithm, what it does is says, again, it sounds like my best, the structure I find in this data is that I think there are 2 underlying audio sources, and here's one of them.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So if not perfect, mostly the voice, a little bit of audio there, but and here's the second audio source. Not too shabby. So it separates out also the counting from 1 to 10 and the music. So you might look at the problem, look at an unsupervised learning algorithm like this and think, how complicated is it to implement this? And it seems like to do all this audio processing, seems like you need to write a ton of code. I'm thinking like, need to link in like a C++ library, process audio. How it seems like a complicated program to do this. It turns out the algorithm to do this problem is 1 line of code shown right there. It did take researchers a long time to come up with this line of code, so I'm not saying this is an easy problem, but it turns out that using the right programming environment is literally, many learning algorithms are literally like 1 or maybe 5, maybe 10 really short programs. I'm not saying this stuff is easy, right? You need to understand this stuff well. And I want to show you this also to explain why, for this class, we're going to use the Octave programming environment. Octave is a free open source software. It's a programming environment that if some of you have used MATLAB before, MATLAB is a commercial platform, but Octave is sort of a free, MATLAB is a commercial platform that, depending on where you are, can actually cost quite a lot. But using a tool like Octave or MATLAB, many learning algorithms become just a few lines of code to implement. And so later on in this class, I actually teach you a little bit about how to use Octave as well. And we'll be implementing some of these learning algorithms in Octave, or if you have MATLAB, you can use that too. It turns out that in Silicon Valley, for a lot of machine learning applications, what we do is first prototype our software in Octave, because software like Octave makes it incredibly fast to implement these learning algorithms. Here, each of these functions, like SVD, stands for singular value decomposition, is a linear algebra routine that is just built into Octave. If you were doing this in C++ or Java, this would be many, many lines of code of linking in complex C++ or Java libraries or whatever. And these functions, you can do all this stuff in C++, Java, Python, but it's just much more complicated. So what I've seen after having taught machine learning for like a decade now is that usually you learn much faster if you use Octave as your programming environment, and if you use this to learn the tools quickly and use this to even prototype your learning algorithms. And what many people will do, and frankly the brand name, the largest Silicon Valley companies will do, is use a language like Octave to prototype the learning algorithms, and only after you've gotten it to work quickly, then migrate it to C++ or Java or whatever. And it turns out that by doing things this way, you can actually get your algorithms to work much faster than if you were to start off in C++. So as an instructor, I get to say, trust me on this one only a finite number of times. But for those of you that don't know, that haven't used these environments before, I'm going to ask you to trust me on this one. And even when you're deploying very serious learning applications, if you think about what will get you there the most quickly, very often prototyping in a language like Octave first, or MATLAB if you have it, but MATLAB is expensive often. But the prototyping language like Octave first, and only then, after you have it working, implementing it in C++ or Java or whatever, that's usually a much faster way to get your learning algorithm working than if you were to start off coding in like C++ Java. Finally, to wrap up this video, one quick review question. Talked about unsupervised learning, which is this learning setting where we just give the algorithm a ton of data and ask it to find structure in the data for us. So of the following 4 examples, which ones would you use using an unsupervised as opposed to a supervised learning algorithm? For each of the 4 checkboxes on the left, so check all of the checkboxes on the left for which you think you would use an unsupervised learning algorithm, and then hit the button on the lower right to check your answer. So hopefully you remember, right, the spam filter problem. Well, if you have labeled data, treat this as a supervised learning problem. The news story example, that's exactly the Google News example. And so we saw earlier in this video how you can do that using a clustering algorithm. The market segmentation algorithm, I also talked about that briefly, right? If I don't know in advance what my market segments are, if I just give my algorithm data and ask it to discover the market segments automatically, that's also unsupervised learning. And this final example, this is just like our breast cancer diagnosis example, right? Given the set of patients of having only here I talked about diabetes, but this last example is just like if you have examples of patients with and without diabetes, that's a lot like our early example of having labeled data of patients with and without breast cancer and trying to diagnose that. So that's it for what is unsupervised learning. Next, let's start to actually delve into learning algorithms and learn about some specific algorithms.